This video is about doing finite element modeling in ANSYS to get the stress distribution and the stress concentration for this rectangular plate containing a circular hole. And this plate is in plane stress condition. And note we are going to use adaptive sizing for this benefits and resolution 5. In Workbench, we are going to use the geometry we just created, and now create static structure. Before we do that, we need to click on this geometry and right-click for properties and change the analysis type to two-dimensional, 2D. And now create static structural analysis to link the geometry and update the model. And double click to open the model. And first need to make sure we're using millimeter and ton for the unit system. And then in the geometry, we can see 2D behavior is plane stress. And there are other options like plane strain, axis symmetric. So here note there is the thickness by default is 1 meter, 1000 millimeters. So better change this to 1 millimeter. So this thickness will determine the cross section of the plate, which will affect the stress given tensile load. So material, structural steel, and for mesh, we go to sizing and change adaptive sizing to yes, and the resolution 5, and we can create mesh. We can view in this angle, and on static structure, apply boundary conditions. So a displacement on this edge to constrain x movement, and the displacement on this edge to constrain y movement, and apply a force on this edge. So change to component, X component, 10,000 newtons, in order to produce a nominal stress of 100 megapascals. And for solution, insert stress, a normal stress, X component. And if you wish, you can also look at von Mises equivalent stress. And here we could introduce convergence. And here, this like refinement can be automatically done given some criterion. So need to increase this number to more than 1. So that means how many loops the software will go. And on this normal stress, we insert like a convergence here and set the allowable change, which is the criterion. So let's say change to 1%. And now we can solve so we can check the curve for convergence. So note the change of the first refinement and now the second refinement. So that means the program converged. And we can see the maximum stress located at these two edges of the hole. And for the results, we can create a parameter for the maximum normal stress. So this is the von Mises, so quite close. And now we can close ANSYS Mechanical. Double click to open parameter set. Now we have 3 input parameters. They are like geometric parameters or like dimensions. And one output is the maximum normal stress. Now we actually applied a nominal stress of 100 megapascals. So here we can just calculate the stress concentration based on the maximum normal stress, that P4. And here we just divide by 100. So in order to enter unit, we use a square bracket, megapascal. So the output, like Chinese stress. Stress concentration factor is 2.98. nearly 3. So now what we can do is we can change the diameter to create a new so-called design point, and we can update. You could select, right click to update the selected design points only, or you can update all design points. And you can check the progress here. Now we got some new values for normal stress and the stress concentration factor. Okay, thank you.